So in the previous videos we looked at arithmetic progressions. Now we've got geometric progressions. Now where arithmetic means plus or minus, geometric means sort of multiplying, possibly dividing. And so a geometric progression is just a sequence that rather than adding something each term, it multiplies by something each term. So for example, I could have a sequence that went 3, 6, 12, 24, 48, etc. And this one is going from one term to the next, and it's multiplying by 2 times 2 times 2 times 2 times 2. And for a sequence like this, the term-to-term definition is fairly easy. I can just say, as always, let's call this one the sequence x. So I can say x1 is 3, and xn plus 1 is 2 times xn. I'm just taking the previous term and multiplying it by 2. So this will generate that whole sequence. And for the nth term definition, perhaps a little bit trickier, but I'm going to say, well, xn is, well, I'm going to start with 3, and I'm going to times it by 2 a certain number of times. Now for the first term, I haven't times it by 2 at all. You need to be good with indices here, but just times it by 1 would be 2 to the 0. Then on the second term, I've times it by 2 once. For the third time, I've times it by 2 twice. So actually what we get here is times 2 to the n minus 1. So with n equals 1 here, this becomes x1 equals 3 times 2 to the 0, and 2 to the 0 is just 1, so that's just 3. For x2, I get 3 times 2 to the 1, which is 3 times 2, that's 6. For x3, I get 3 times 2 squared, that's 3 times 4, that's 12. So that form means we keep multiplying by 2, and it gives us that geometric progression. Here's another one then, let's call it yn, so 4, 40, 400, 4000. Term-to-term definition, well, we can see it starts at 4, so y1 is 4, and to go from yn to yn plus 1, we times by 10, so it's 10 times yn. And as before, the nth term definition, when I've got yn, I'm going to start at 4, and I'm going to multiply by 10 n minus 1 times. So initially no times, then 1 time, then twice, then 3 times, then 4 times. Okay, so that's another example. Here's another one. This is still a geometric progression, but rather than multiplying, we're dividing. So we're dividing by 2 from one term to the next. We don't need to think about this in any different way. Same way with arithmetic progressions. You know, when I subtract, that's just adding on a negative number. Similarly, when I divide, that's just timesing by a fraction. So actually, we can just think about this as timesing by 1/2 from one term to the next, and then it's just the same as it was before. So I can just say for the term to term, x1 is 100, and xn plus 1 is 1/2 of xn. And then similarly for the nth term definition, I can just say start at 100, and then multiply by 1/2 n minus 1 times. Okay. So let's think about the general form for a geometric progression. Well, as before, as for an arithmetic progression, I'm going to call the first term a, and now rather than adding on what we had the common difference before d, I'm going to call it r. So I'm going to multiply, and I'm multiplying by it. So before in the AP it was a plus d, now it's a times r. And then to get to the next term, I multiply by r again, so I get a times r, which is ar squared. Then ar cubed, ar to the 4, etc. And this value r, we can sometimes refer to as the common ratio. It's the common sort of multiplicative factor of going from one term to the next. So for example, if I had that sequence, let's say 2, 6, 18, 54, 162, etc., then this one has a equals 2 and r equals 3, because I'm starting at 2, I'm doing 2 times 3, then I'm timesing it by 3 again, timesing it by 3 again, timesing it by 3 again. Okay, so the term-to-term definition, it just says, let's call this sequence x, so xn, so it's going to have xn. Well, firstly for my term-to-term definition, I start with x1 is a, and then the n plus first term is r times the nth term. So the general definition is xn plus 1 is r times xn. So here a is 2 and r is 3, so I'm just saying the first one is 2, and then times by 3 to get to the next one, times by 3 again. And then for the nth term definition, we copy the style of what we were doing in the examples and say, well, xn, we just start at a, and I multiply by the common ratio n minus 1 times, so it's times r to the n minus 1. Okay. So, and notice this doesn't mean a times r to the n minus 1, it's, you know, if you want to, you could put brackets in here. You don't need the brackets, but that's maybe less confusing. Might help if you're at all confused by this. It's just that number a once, and then timesing by r n minus 1 times to get to the nth term. So for example here, x3 is a times r to the 3 minus 1, a times r squared. In this particular example, it's 2 times 3 squared, which is 2 times 9, which gives me that term here, 18. Sorry, that's gone off the page. 2 times 3 squared is 18. So just to summarize therefore, our general geometric progression, AR squared, where a is the first term and r is the common ratio, we've got the term-to-term definition and the nth term definition. The term-to-term is x1 is a, xn plus 1 is r times xn, and for the nth term, xn is a times r to the n minus 1.